Hey everybody, this video is going to talk about exponential applications. So we're going to start with exponential growth and decay, which you've probably seen before in Algebra 1 and maybe even biology class where you're looking at population growths or maybe, a population's going extinct, something along those lines. So I want you to pause and copy down these formulas. Now notice that our formula for growth and decay looks very similar, except growth has a plus here, decay has a minus here. Now the reason that there's a 1 there is because 1 is really representing 100%. Okay, it's saying, okay, we start with 100% of our initial amount, and we are either growing, so we're adding some percentage to that, or we're decaying, meaning we're subtracting some percentage away from that. So that's the only difference in the formula. Okay. A is always going to represent your starting amount. R is going to be your rate, okay, and you have to represent it as a decimal, and then T is just your unit of time. So if we look at an example here, okay, we see the original value of an investment is $1,800. So I'm going to start by just making a list of all of my variables, everything I'm going to plug into my formula. Okay, if the value has increased, so we're doing growth, by 7%, that means we're going to use 0.07. To represent that percentage. If you're not sure how to do that, you're really just dividing your percentage by 100 and using that decimal. Now we want to write an exponential function to model the situation and then find the value of the investment after 15 years. So that's our t value. So let's plug in everything. So if we're just writing a general formula that could represent this, we're not going to be plugging in anything for t yet. So it would just be our initial amount of 1,800, and then we have growth, so it's going to be 1 plus 0.07 raised to the t power. And we could use this formula to find the value of the investment after any given number of years. If we want to know specifically after 15 years what the value is, then we just have to plug 15 in. So we're just evaluating the function at that particular t value. So when we do this calculation in our calculator, we're going to find that the value of this investment has jumped up a good bit to almost $5,000. Okay, we're at $4,966, and then we can go 26 cents here. So let's look at a decay problem. Okay, so similar setup. Okay, Mark bought a brand new car for $35,000. So there's my initial amount. And it's in 2018, and that's going to come up later. So if the car depreciates, meaning it loses value, we have decay, approximately 8% each year. Okay, well, there's my rate. Again, divide by 100, get your decimal, 0.08 here. So we still want to write a function to model the situation and then find the value of the car in 2025. So they're not directly giving us a time here. Okay, but if you bought it in 2018 and we want to know the value in 2025, we know that 7 years have passed here. So we're going to use t value of 7. Do not plug in 2025. Okay, so let's just write our general function again. All right, we've got our starting amounts. Now, since it's decay, we are subtracting our rate away from 1. So we're going to have 1 minus 0.08, which is going to leave us with 0.92, and then to the t power. So if we're looking for the value after 7 years, we're just plugging in 7. Plug it in our calculator to make the calculation, and we're going to find that the car is now only worth $19,524. That's not a 4. There we go. And 63 cents. Now, the other type of problem that you might see, and again, I want you to copy down the formula and what all the variables represent here, is what we call a compound interest problem. And this is used when interest is calculated on the principal or starting amount and the interest that we have already gained. Okay, and that could be a good thing or, maybe a bad thing. If it's an investment account, you're trying to save money, that's a good thing because your money is making money. Okay, but if it's something like, a car loan, a house mortgage, something like that, that can really build up the amount that you owe overall. So we have more variables here. Okay, rate is still a decimal. Like I said, P is now going to represent our initial amount. And a lot of times we will make this or refer to this as the principal. And then N is going to be something new. So N is the number of times that it's compounded each year. So I want you to copy all of these values down as well, because depending on the problem that we have, we're going to be using a different N value. If something's compounded, let's say quarterly, that means it's going to happen 4 times a year, weekly, 52, and so on. So you want to know all of these values so that we can figure out what our N value is within our problem. So let's look at an example here. So again, we're going to want to start by identifying all of these values. So P, R, N, and T. These are the things that we want to identify as we read through. So Laura deposited $12,000 into an account. Okay, so that is our starting amount. That is our principal. Okay, and it earns 8% interest. So that's our rate. Okay, again, represented as a decimal. Okay, we want to know how much money will she have in 5 years, so that's my T, if the interest is compounded quarterly. Well, if you go back to our list here, okay, quarterly meant that we are compounding 4 times each year. So we're going to use 4 for our N value. So we're just going to plug it into our formula first, okay, and then we can plug in our specific time value here. So if we're doing just a generic formula, that we could use for any given number of years, it would be 12,000 times 1 plus, I'm just going to write it out like this because it's a little too hard to actually do the math in your head here, okay? We are doing our rate divided by N, the number of times it's compounded, raised to the NT power, so 4T. Okay, so that's your general formula. Now, if we want to know the value after 5 years, we're plugging in 5. Okay, and this is going to be a little bit trickier to type into your calculator. Make sure you're using lots of parentheses to make sure that it's following the order of operations as it should. So in this case, you should find that after 5 years, her investment will now be worth $17,831.37. All right, we will be doing a lot more of these kind of problems in class. Let me know if you have any questions, and have a wonderful rest of your day.